Hello, this is Miss Oliva, and I'm going to make a video to help you hopefully with 1.6, which is about transformations with graphs. So let's get started. Okay, so transformations with graphs isn't so bad as long as you learn the rules, like most of the stuff that we've been doing. And if you make sure you understand what the graphs look like to begin with. So what do I mean by that? One type of graph we're going to be looking at is an x squared graph or a quadratic. So from now on, you're going to hear a lot about quadratics. So anytime you hear something about a quadratic, it's something with an x squared. And this is the most basic quadratic you could have, meaning there's nothing being added or subtracted or multiplied. So the most basic type of each graph is called the parent graph. So we need to know what that looks like, and then we can use all these transformation rules. So if I were to plug in a few x's, so I could pick any of these because x is the independent variable, and then I can plug it in to see what I would get here, the y, which is the dependent variable. So if I plug in -1, be careful, make sure you know that -1 squared really means -1 times -1. So that would be +1. 0 squared is 0, 1 squared is 1. So let me plot these points. If I did do more, just to give you an idea, 2 would give me 4 because 2 squared is 4, and -2 would also give me 4, just to give you a little more points, but really we're going to focus on these three. So that is what a parabola looks like. That is what our parent graph looks like in this case. And this is the table we're going to keep coming back to figure out what we should do with these transformations. So here is the first type of transformation. So I'm going to keep saying that things are happening inside the function or outside the function. What I mean by that in this case is inside what is being squared. So this is considered inside. This is inside. Here would be something happening outside because it's outside of the x squared. If it's inside, it happens to the x, which means it's horizontal, some kind of horizontal change. And the trick about the horizontal stuff is it's always the opposite of what you would guess. So if I told you that this +2 moved us horizontally, which means right or left, you would probably guess right. But it actually moves us left 2. And the fancy name for that is a horizontal shift. So left 2 isn't so bad. I could just take this graph, move it to the left, and draw it again. But these problems are going to get harder and harder. So I want to teach you a strategy now that will work even when I give you a whole bunch of transformations. So if it happens inside, it happens to the x. And if it's happening to the x, we do the opposite here. So instead of +2, I'm going to write that all of my x's should be subtracted by 2. Since nothing is happening outside of the function, either here or here, nothing happens to the y. So we go back to our parent graph points and we do these changes to them. So I'm going to take this -1 and I'm going to subtract 2. I'm going to take this 0 and I'm going to subtract 2. 1 minus 2. And then for the y's, they should all stay the same. So -3, 1 is my first point, -2, 0, and -1, 1. And it should look the exact same as our other graph, just shifted 2 to the left. Okay, so this is another horizontal shift because it's happening inside the function and it's something being added or subtracted. Anytime we're adding or subtracting, we're going to call it some kind of shift. So this one again, -3 is going to do the opposite of what we would have guessed. And it's going to take us to the right 3. So when I go to my table, I'm going to say that I need to add 3 to all of my x's, and my y's again are going to stay the same. So don't forget that every time we're doing this, we're starting with our parent graph numbers. So it's the -1 I'm going to plug in here and add 3. Sorry, we're plugging in here. -1 plus 3. I'm going to take my 0 plus 3. I'm going to take my 1 plus 3, and then my y values stay the same. 2, 1, 3, 0, 4, 1. So I'm going to show you some of the homework questions today to show you that, yes, there are going to be some that you really don't have to do the whole table for. But again, why am I showing you the table right now? So that you learn how to do it for the hard ones. Okay, so here's a case where we're adding again. So this is definitely a shift. But since it's outside of the function, it's not in here being squared, it is a vertical shift. Vertical shifts do exactly what you think they would do. So if I told you it was a vertical shift, meaning up or down, +1, I'm pretty sure most of you would guess goes up 1, and that is correct. So we do exactly what it says to the y. When it's an x, we do the opposite. When it's something happening to the y, we do exactly what we see. So this time my x's are staying the same, which means -1, 0, and 1. Because I'm going back to my parent numbers here. But for my y's, I'm going to add 1 for each one. So -1, 2, 0, 1, and whoa, I did this wrong. Sorry. This was a 1, a 0, and a 1, so this should have been a 2 also. But I knew right away something was wrong because the shape was not going to be right. So I just kind of assumed there was a pattern. So don't assume there's a pattern because it's not always a pattern. All right. So again, could you have just taken your original and just moved the whole thing up 1? Yes. But I just want to make sure you know how to do it with the chart. So outside, that means vertical. So this is a vertical shift. And so I just do exactly what I see to the y. X's stay the same, -1, 0, and 1. Y's, I need to subtract 2. So 1 minus 2, 0 minus 2, 1 minus 2. So -1, -1, 0, -2, 1, -1. Same old parabola, just moved down 2, shifted down 2. Okay, let's see what's happening to this. When there's a negative being multiplied, first of all, it is called a reflection. But a reflection is kind of like a flip. So a reflection could flip the graph down, or it could flip it from right to left. So this is outside of the function again, because inside the function would look like that. You see the difference? So we'll see that in a second, but right now that is outside. So outside affects the y. So if I plug in my points, the x's stay the same, but the y's will all become the opposite of whatever they were before. So here are my points. So -1, -1, 0, 0, 1, -1. So apparently, when there's a reflection which affects the y, it really flipped the whole graph down. But if it was already down, it would have flipped it up. So the easier way to say it instead of up or down is that it flipped the graph over this line. Remember, this line is actually the x-axis. So this confuses a lot of people because we're saying it's a vertical thing, we're saying it affects the y, but then we're describing it as reflecting over the x-axis. But hopefully you can physically see that that is exactly what it's doing. So it's a reflection over the x-axis is the fancy name for it. Remember, you can pause or rewind and watch something again if I'm ever going too fast. Okay, most of you could probably guess what's going to happen this time because it's still a negative. So it's going to be a reflection, but the negative is inside. So it's going to affect the x's, but it's probably going to be called a reflection over the y-axis. Because if last time we flipped over the x, this time we're probably flipping from left to right over the y, right? Because this is our x and this is our y. So let's check. If I change all of my x's, so my -1 becomes 1, my 0 stays 0, and my 1 becomes -1, but the y's are staying the same. So that's 1, 0, 1. Let's look what happens. 1, 1, 0, 0, -1, 1. It looks exactly the same as it did before, which makes it seem like nothing happened, but something really did happen. This graph did flip, but the stuff on the right flipped over to the left, and the stuff at the left flipped over to the right. So it ended up kind of just flipping each thing over and looking the same as it started. But make sure you understand that a negative inside does still reflect the graph over the y. Okay, so we've done adding and subtracting inside, adding and subtracting outside, and we've dealt with the negatives. So the only thing left really is when we're multiplying by some kind of a number. Okay? So some kind of a number, meaning is it a number larger than 1 or is it a number smaller than 1? Because they do different things. So if it is larger than 1 and it's outside, so remember outside is usually a vertical something. It's not a shift because I'm not adding or subtracting. So this is called a vertical stretch or a vertical compression. So if it's a larger number than 1, we're going to say we're stretching it out. Where if it was smaller than 1, we're kind of pushing it together, we're compressing it. So this is a vertical stretch of exactly what we see, because the y stuff is always easier. It's exactly what we see. So I go to the y and I tell it to do what I see, multiply by 2. So don't forget your parent numbers. I put them here so that we can see them if you still don't have them completely memorized. So x's are staying the same. Y's need to be multiplied by 2. So -1, 2, 0, 0, 1, 2. Again, we have our same old parabola, but do you see why it's called a stretch, a vertical stretch? Because up and down, it kind of stretched a little faster or kind of made it skinnier, right? Because it's going to go 1, 2, and then it'll be 2 instead of 4, it'll go 2 all the way up to 8. So basically, it's going to get higher faster. So what if it is a number less than 1? It's outside, so it's still called a vertical. But since it's a smaller number, it's a vertical compression. And again, since we're dealing with the vertical stuff, it's exactly as it seems. So it's a vertical compression of 1/4. And what I do to my chart is exactly what it says. So x's stay the same again. Y's need to be multiplied by 1/4. So 1/4, 0, 1/4. So going up very, very little. If you wanted to maybe do another point just to get a nicer point, let's try 2. When x is 2, remember we talked about how y is normally 4. So 4 times 1/4 would be 1. So just to get an idea, so obviously that'd be the same on this side. So do you see why it's called a compression? Because now it's going up at a much lower rate and the graph has been kind of pushed down if we were thinking vertically. So big number stretches, small number compresses. That should make sense and seem like it's not too hard to remember. But the problem is when we go inside, everything's the exact opposite. So it's easy to get confused, which is why you should need to really practice these. So I see a 2 being multiplied inside. I'm thinking horizontal. The second I see inside, I'm thinking, okay, let me slow down here because everything's going to be the opposite of what I would guess. So big numbers usually mean compression, stretches, right? So this time it's going to be the opposite. So horizontal compression of, and now be careful here too, because remember when we saw a +3, we really did x minus, and we saw a minus something, we would really do x plus. Well, when we see ×2, we're really going to multiply by the reciprocal. And that's what we say here as well, is a horizontal compression of 1/2. So that's what we do to the x's, multiply them by 1/2. So that would be -1/2, 0, and 1/2. The y's stay the same. So where are we at? If this is -1, I'm going to go to -1/2, 1, 0, 0, 1/2, 1. So this looks like a stretch, but that's if we were thinking vertically, up or down. Think of this as what happened horizontally. Horizontally, didn't the graph actually get smushed in a little bit? So from left to right, it normally would have been here, but now it got squished in. So that's why we call it a horizontal compression. So again, opposite. So it's a horizontal, but we see a 1/4, so we say the opposite of what we think. So we're going to say stretch of, flip the number because we do the opposite of everything that's inside. So instead of 1/4, we do 4/1, which is just 4. And that's exactly what I need to use to multiply. So 1 becomes 4, 0 is still 0, -1 becomes -4. The y's do not change, so 1, 0, 1. So 4, 1, 0, 0, -4, 1. So again, think of this horizontally. If I'm thinking about what happened to the graph horizontally, it did get wider. It stretched out horizontally. Okay, let's do one where we're doing a lot of things, and then I'm going to do some of the ones from the homework to show you exactly how to do it on the homework with all the buttons that are being used there. Okay, so what's happening here? First of all, I see x squared, so I'm back to my parent graph here. Now, what's happening with the x? I have a +3, so I really need to do -3. I don't have anything being multiplied in here, so I think that's it for the x. But for the y, I have a 2 being multiplied, and I have that negative that's a reflection. So we need both of those. And then we have this -1 out back, so we need that too. But I didn't have to do the opposite of any of these things. Remember, the y stuff is easier. You do exactly what it says. Only stuff inside the function needs to become the opposite. So now let me carefully use my original points to change them. -1 minus 3 would be -4. 0 minus 3, 1 minus 3. Over here, I plug in the value 1, multiply it first, so that gives me -2 minus 1. Plug in my 0, that gives me 0 minus 1. And I plug in my 1, that gives me -2 minus 1. So -4, -3, -3, -1, and -2, -3. It makes sense that it's going down because of that negative, and it makes sense that it seems like it's a little skinnier than normal because of that too. Otherwise, it moved left 3 and down 1. All right, so let's do some from the homework to see what other types of functions. So this is a different type of function. It's an absolute value function, but they're showing you exactly what it looks like. So you could make your little parent graph chart if you needed to. But if there's only just one little transformation that's just like adding or subtracting, you can probably do this one without the charts. So I'm just going to go use this button, which means I want to move it left, right, up, or down. I'm just going to move this down 5, and luckily it will move the whole thing with me. So as long as I tell it the right thing to do, these aren't too bad. Okay. So this is a weird graph as well. The parent graph is just 1 over x, and this is exactly what 1 over x looks like. But all that's really important here is what would plus 2 do to this graph? So I'm going to again use my little translation button. See if it'll let me move it from here. No. So I'm going to pick point. So it was here. So make sure you go up 2, and you should be fine. Okay, I'm going to let you do this one. This one is left 1, right? Remember opposite. So you can just move this whole graph left 1. This one means right 3 and up 5. But again, anything up, down, left, or right, it's not too bad to just do it without the chart. Right 3, just make sure always doing the opposite of the inside. Up 5. So it was just 2 different things, but they're both still pretty simple. This means multiply by 3. So this one you might want to do on your chart. So let me just show you this real fast. Okay, so just to give you a little overview for absolute value, here's what the parent graph looks like. Because this is a graph you need to become more comfortable with. The parent graph always starts at 0, 0, goes over 1, up 1. So this is so far just like our parabola, except for our parabola is curved and absolute value is completely straight. So it's the next part that's different. Remember, with a parabola, we would do 2 go up to 4. But we're not squaring anything here. So we're just doing the absolute value. So what is the absolute value of 2? 2. What is the absolute value of negative 2? 2. So it's just straight lines on both sides. So that's the parent graph. So for my chart, -1, 0, 1, 1, 0, 1. It's actually the same as my parabola, but I know that I'm going to be doing straight lines instead of curves. So in the example, it was just a 3, I believe, outside. Yes, so just a 3 outside. So outside is going to affect the y, and we do it exactly as we see. So I'm just going to do this one on my chart real fast and then go back. So on my chart, I just need to multiply all the y values by 3. Okay, now that I know what points I want, let me just go shift things around to make it look the way I want it to look. Sorry, it's kind of a pain going back and forth. And I lost where I was. Sorry, hold on a second. I lost it, so now it's probably gonna be a little different, but we can do it. Okay, it's exactly the same. Good. Okay, sorry. Here we go. So I know where my points want to be. So let me just figure out how to do it. Translation's not going to work because it's going to keep this graph the exact same shape and just move it left, right, up, or down. So this is where these two come into hand or come into play. So doesn't it look like this one has the arrows going left and right? So this button is for if I want to do a horizontal stretch or compression. And this one is if I want to do a vertical, which is what I want. I want to do a vertical one and I want to change it. So this point, which was 1, 1, becomes 1, 3. So I already know from my chart where I want that point to be. So if I can at least change that 1 point, it shifts the whole graph correctly for me. So it's not too bad. Okay, so I would do the same thing for this one. I would just multiply all my y values by 1/4 and then play around with this to see where you'd want it to be. It would become 1/4. So you kind of have to guesstimate here where that would be. So I'm going to guess it's there. So it's not too bad. All right, now for weird graphs. This is not a graph that you should know. This is just a random graph. They're calling it G. But then they're saying, what would it look like if we asked you to do this transformation to G? Well, if you listed those points for G, because that's kind of our parent graph now, even though it's not a shape we are familiar with, I'm going to just put those on my table. So -2, 0 is a point I see. -1, -4. 1, -4. And 2, 0. So that's apparently my parent graph. And what do they want me to do to it? Multiply by 2 on the outside. That's what that means when they have the 2 outside of the g of x. So they're basically telling me to multiply my y values by 2. So what would that do? So the first thing I did was make a chart for this function they're calling g of x. Doesn't matter if I've never seen it before. Here's my g of x. I just wrote down those 4 points I could see from the graph. And now I'm going to do the transformation they wanted me to do, which was this. So my x's stay the same, but my y's get multiplied by 2. So now I'm going to go and I'm going to move all the points to these new points. Okay, so -2, 0 actually stays where it's at, but wait, I think they want me to do it down here. Okay, so instead of moving it around, we have to make a new graph. So we pick the segment. The first point we want is -2, 0. So I click that. The next one is -1, -8. Okay, now I'm gonna have to hit segment again to do the next line, which starts there, but goes to my next point of +1, -8. And then finally, I'm gonna start there and go to my last point, which was 2, 0. So it should look similar, just since this one was multiplied by 2, it stretched. So it looks right to me. Let me check. So same thing here. I'm not going to do this one, but list all 4 of these points and then do the correct transformation. Since that 1/2 is inside the function, you are going to multiply your x's by 2. Remember the opposite. So you're going to write all 4 of these points and then do the transformation, which in this case is just multiplying each x by 2, and then you'll plot your new points. All right, back to a normal absolute value. All that's happened is there's a negative, so there's a nice button for that. The negative outside flips it up and down, right? It flips it over the x. So all I have to do is hit that button. So you just have to know which button to hit. Which one are you flipping? Same idea. It's just going to flip it over the y-axis because the negative is inside the function. So it'll just be something like that. Same thing here. Flip it over the x. So that's just a matter of knowing what the negatives mean. This is a fancy graph. So this one I would maybe plot your points or write them on a table. So there's 1, 2, 3, 4 points. I put them on a table. And then I would multiply all of the x's by -1 and see what my new 4 points are. Just make sure at the end the one that had an open circle still has an open circle wherever it ends up. So you can see the buttons here. So you're going to use this 1, 2, 3 times. So there's 3 different lines you're going to be drawing. 1, 2, 3. And then at the end, you're just going to make sure to make it an open circle. Sounds a little tricky. You can let me know if you need more help than that when you try it. Okay, this one's just asking me to explain things. The graph of this has done what if the parent graph is x squared? So what are the 3 transformations? So did it go left 2 or right 2? Well, we know it went right because it goes the opposite of what we would think. What is the reflection over, the x or the y? Well, since it's out front, we are reflecting over the x. And then finally, that plus 2 at the end moves us up 4. And then it would want you to graph it. So since there's a lot going on here, I would do the chart. I would make your chart and then I would play around with the buttons to make sure it looks the way you think it should look. All right, finally, square root. Last graph we're going to talk about, I think. So let me give you the crash course and then we can look at it. So what does the parent graph look like and what would its chart be? So y equals square root of x. If you don't know what it looks like, let's just try to find some points first. So let's just use our same -1 and 1 for now, and then we might change our mind and add some more. So first, -1. If I try to plug in -1, it's not going to work because we can't take the square root of a negative. So we would either get an imaginary number, which means it's not going to be on here, or we just say we can't do it. So that was a bad choice, which is fine. So now let's try 0. Would 0 be a good choice? Yeah, square root of 0 is fine. It is 0. How about 1? Square root of 1 is 1, so that's fine. I would normally try 2 next, but I can already see that, oh, square root of 2 is not going to be nice. So let me pick the next nice number that if I take the square root, I don't get a decimal. Wouldn't that be 4? Square root of 4 is 2. So these are going to be kind of my starting points for my parent function. 0, 0, 1, 1, and 4, 2. So you'll see it's just kind of like a half curved line. Never goes down here unless there's some kind of shift. So if I wanted to do -2 square root of x minus 1, I would use these points and do what I'm supposed to do. So the -1 here would make me add 1 to my x's, and the -2 out here would have me multiply my y's by 2. So 0 would become 1, 1 would become 2, 4 would become 5. 0 would stay 0, 1 would become -2, 2 would become -4. 1, 0, 2, -2, 5, -4. Makes sense that it flipped it and that it's going down at a much bigger rate or faster rate than it was before because of that ×2. Okay, so this one you would need to add 2 and then flip it or vice versa. But again, if there's more than one thing happening, I would maybe just do your chart to make sure you know what points you want and then play around with the buttons to make sure you get to those exact points. This one has 2 things happening also, so I would probably do it in the notes. And this has a lot, so I'd probably do that in the notes, meaning write your points and then go to the chart. Okay, let's just look at the last two on the homework because those are a little tricky. So this one I'm not going to do, but it's just asking you to pick. Wait, I thought it was asking you to pick, but maybe not. All right, it's asking you to graph the function given these two things. So just remember that the negative 1/4 on the outside affects the y. So I would do a chart and multiply all. So I would plot, or I would write on my table 1, 2, 3, 4, probably all 5 of these points. You see how there's 5 points you can clearly see? And then I would multiply all of the y values by negative 1/4, but then be careful with the x. Do not multiply by 1/4 for the x. Remember, you're going to multiply by 2. So I just wanted to point that out. And then finally, this one's a little odd, but it's not as hard as it looks. It's just asking you to match. So it's telling me this is my parent graph, which is unusual because our parent graphs are usually very simple, right? X squared by itself, square root of x by itself. Well, they're just saying, here's my parent graph. It happens to be x to the third plus 2x squared. But here's what it looks like. What graph would match these other ones? So if you look at A and compare it to what we had before, what is the difference? Do you see that it has been multiplied by 2? So since the whole thing has been multiplied by 2, that is like a vertical shift of 2. So the 0, 0 point would still be 0, 0, right? But looking at this next point over here, it would be higher because that 1 point whatever would have been multiplied by 2 also. So I'm going to look for a graph that still has the 0, 0, but looks like that kind of bump is higher. So the only one that still has the 0, 0 is this one. So 2, it must be 2. So equation A matches graph 2. The transformation used is a vertical, because it was multiplied by 2 on the outside, stretch. Okay, I'll do one more, or I'll at least talk about the next two. What's the only difference between where we started and B? Well, they both have x squared, they both have 2x squared, so nothing's been changed there. But this one has this big old -2 at the end. Isn't that going to shift the whole graph down too? And the fancy name is a vertical shift. And then looking at C, obviously something's happening inside because it's happening in both spots where there was an X. It now has a parenthesis with stuff happening to it. And in both cases, it's +2. So we need to do the opposite and realize that this has moved the graph left 2. So left 2 looks like that first one, right? So C matches number 1. And the fancy name for it is just a horizontal shift. Okay, that's it for today. I hope that helps with the homework. If not, let me know if you have more questions.